All right, we're going to be studying section 1.4 in this video. We're going to talk about the characteristics and definition of a function. It ends up sounding a lot worse than it actually is. I'm going to make an analogy to a post office, and I think that'll help out. So on this first video, we're going to talk about the definition of a function and the characteristics of a function. On the next video, we're going to talk about determining what the domain of a function is. So one way of thinking about a function is to compare it to a post office. The post office has a bunch of letters, and those are individual X values, and they need to be delivered to mailboxes. Each mailbox is a specific Y value. In order to be a function, every single letter has to be delivered to a mailbox. All right, it'll make more sense as we go through this and explain a little more. First, the formal definition. A function f from set A to set B is a relationship that assigns to each element x in the set A exactly one element y in the set B. The set A is referred to as the domain of function f. The set B is referred to as the range. So that's the formal definition, and now I want to get into some characteristics of it. There's going to be 4 different characteristics we're going to talk about. First, we're going to make an analogy with the post office for all 4 of those characteristics, and then we're going to use an actual function and show how each characteristic applies to a function. So the first characteristic is that every element in A must be matched with an element of B. All right, so for the sake of our comparison, you need to understand that the post office represents set A, and in that post office is an element X, a letter. All right, the town residents represent set B, and every individual mailbox is an element of Y, or element Y of set B. All right, so basically that's like saying the x-axis is the post office, and every element X is a letter in the post office. The y-axis is all the town residents, and each mailbox, it belongs to a town resident. So that first characteristic that I mentioned is like saying that every letter must get delivered to a mailbox. All right. The second characteristic. Some elements in B may not be matched with any elements in A. So using the same analogy, some mailboxes may not get a letter delivered to them. Don't be upset. They're jerks. They don't deserve mail. All right, the third characteristic is that 2 or more elements in A may be matched with the same element in B. Which is like saying that some mailboxes may end up getting more than one letter sent to them. And the fourth criteria, an element in A cannot be matched with 2 different elements in B. And that's like saying the same specific letter cannot be delivered to multiple mailboxes. It can only go to one mailbox. Yeah, I know, it's really getting annoying, that dinging. All right, so that should make sense. If you have one letter and you need to deliver it to two different people, what are you going to do? Rip it in half and give a half to each of them? No, it can't be done. All right, so I think the mailbox analogy is a good one. I think the formal definition is a little bit confusing, as well as the characteristics if you think about it in a math context. But we're going to use one example and show you how all four of those characteristics apply. We're going to do so with this equation, or this function, which is just a parabola. I have no idea what the equation is. Doesn't matter. It's just a simple parabola. Each element in A must be matched with an element in B. Okay, A corresponds to the x-axis. All right, in other words, this was set A, which is letters, and this was set B, which is mailboxes. And this is just a smiley face, which I'm sure none of you have right now. But I do. So anyways, A corresponds to X values. If you look at our graph, we can't show all of them, but you know that this parabola that we have going on here, it still goes on forever and ever in this direction as well as that direction. So every X is going to have a corresponding Y. Even though X equals 4 does not appear on this graph, we know that it's way up there somewhere. If we had to make a graph that encompassed all the X values, the graph would have to be infinitely large, and I think that might take a little too much time for homework. Characteristic 2. Some elements in B may not be matched with any elements in A. All right. B corresponds to the Y values. Some of the Y values, some of the mailboxes, do not get a letter or an X value. And if you take a look at the graph, everything below that vertex is a mailbox that doesn't get a letter. So some elements in B don't get anything assigned to them. Characteristic 3. 2 or more elements in A may be matched with the same element in B. All right, so I'm going to kind of look at this backwards. This right here, 8, is B, an element in B. It's a mailbox without the L, apparently. Anyways, you'll notice that that 8 crosses the graph in 2 spots. That means it gets 2 pieces of mail. Okay? It gets one letter 0 and one letter negative 7.2. This mailbox gets 2 different letters sent to it. All right, so 2 or more elements in A may be matched with the same element in B. Characteristic 4. An element in A cannot be matched with 2 different elements in B. Okay, so the same value of X cannot go to 2 different mailboxes. And if you take a look at the curve that I have here, or that arrow, I'm sorry, it kind of corresponds with the vertical line test, which is something you guys have heard of before. If a vertical line crosses a graph in more than one spot, then it's not a function. Well, follow that arrow. Okay? It only crosses in one spot, wherever it is. Therefore, this shows that it is a function. Okay, so now that I've talked about the characteristics of a function with the analogy of the mailbox and also a graph, what about an equation? What if all you have is an equation? How do you know if it's a function? Well, basically, just solve the equation for y, which is something you're more than familiar with. It means get it so that it's just y equals and everything else is on the other side. If y is equal to one single function of x, then that means it's a function. But if y is equal to more than one, multiple functions, then it is not a function. So I know you're looking at, you're rolling your eyes, you're trying to think, how in the world could y be equal to more than one function? That doesn't make any sense. Well, that's because you haven't gotten that far in your math. Now you're going to see all different kinds of equations like that. It only looks like one function, right? But if we take it and we solve it for y equals, first we're going to get the 3x squared over. And then how do we get rid of the y squared? We have to square root. But how many of you are forgetting that when you take a square root, you have to use plus or minus, right? The square root of 9 is not just 3, it's plus or minus 3. Well, that means that there's two functions. There's a positive square root of 24 minus x squared, and there's a negative square root of 24 minus x squared. Two different functions. Therefore, our original equation is not a function. So that's how you tell based on an equation. And that is the end of this video. Adios.